Welcome to Cat Food Town. Population 25. We've got 7 round Big B, 14 skinny heterozygous, and 4 little b triangular pointy. So from our initial population values, we can calculate our allelic frequencies. We get 0.56 Big B and 0.44 for little b. That gives us our P and Q values. And so using those, we can take our Hardy-Weinberg equation and calculate our genotypic frequencies, our expected genotypic frequencies. So we get these 3 numbers for Big B, little b, and little b, respectively. So if we take these 3 numbers and multiply them by our total population, we'll get our expected genotypic numbers for our population, assuming we're in Hardy-Weinberg equilibrium. Once we have those numbers, we can take them down here and do a chi-square test where we're doing observed minus expected squared divided by expected. This gives us those 3 numbers. We add those up, we get that number. For our degree of freedom, we have 3 genotypes minus 2 alleles gives us 1 degree of freedom. So our critical value is 3.814. Our number is significantly less than 3.814, so we failed to reject our null hypothesis, which our null hypothesis is that the population of Cat Food Town has Hardy-Weinberg proportions for the shape allele. So it does. Now, knowing that, we can go down here and do our selection. And our selection is against a giant sock puppet monster who likes to eat the round boys, because the pointy ones are hard to stomach and digest. So he only likes to eat the round ones, meaning that our fitness, these ones are going to be more fit to survive than these round boys that are just going to get munched up. So once we assign our fitness numbers, we can do 1.0, 0.875, and 0.5 respectively. So we multiply our initial genotypic frequencies by our fitness number. And our fitness number is going to be called W. So that gives us our unadjusted survivor frequency. So we've got 0.1568, 0.4312, and 0.1936. So we add those up and we get W bar, which is just the sum of our unadjusted survivor frequency. So to calculate our frequency after selection, we do our unadjusted survivor frequency divided by that W bar, which is the sum of them. So that gives us 0.2006, 0.5517, and 0.2477, where this column is the triangle, this column is the skinny, and this column are the round ones. And that's our little formula for that. And so if we take those genotypic frequencies after selection and multiply them back by our total population, we get these numbers for our genotype within our new population. And so we've got 5, 13.79, and about 6.19. And so this indicates that there's going to be a shift from the round ones towards the pointy ones, because these ones are more fit to survive than the round ones that are going to be eaten by the evil sock monster.